The air we breathe, once a symbol of life, now harbors an invisible threat.
Our planet is warming. This is not a future threat, but a present reality. The invisible culprit? Carbon dioxide, a greenhouse gas released from countless sources. But how do we know which sources are most responsible? Just like detectives at a crime scene, scientists can now trace these emissions back to their origins. Imagine a world where we can pinpoint the biggest polluters, hold industries accountable, and make informed decisions to protect our planet. This is no longer science fiction, but the power of scientific investigation. By understanding the sources of carbon emissions, we gain a powerful tool in the fight against climate change. It allows us to target our efforts effectively, focusing on the areas where change is most needed. Every source of carbon dioxide, from a coal-fired power plant to a car's exhaust pipe, leaves a unique fingerprint. This fingerprint lies in the ratio of stable isotopes, which are atoms of the same element with slightly different masses. By analyzing these ratios, scientists can determine the origin of the carbon dioxide. Think of it like a return address on a letter. The isotopic signature of the carbon tells us where it came from, whether it's from burning fossil fuels, deforestation, or other human activities.
Carbon pollution. This excess carbon dioxide, released primarily from burning fossil fuels, is a major driver of global warming. But the atmosphere is a complex mix of gases, making it difficult to pinpoint the exact sources of this pollution. Understanding where these emissions originate is critical for addressing the problem effectively. Imagine trying to track down the source of a liter of oil that has spilled into the ocean. It's a daunting task, but scientists have developed ingenious tools to trace the invisible culprit carbon. By analyzing the unique chemical signatures of carbon emissions, we can identify their sources and understand their journey through the environment. This is akin to detectives using fingerprints to identify suspects. Just as each person has unique fingerprints, different sources of carbon emissions have distinct isotopic compositions.